Hey everybody, welcome back to Not So Sirius. As always, my name is Tommy, and today I'm joined with Sam, Joe, and Michael. Following last week's episode on interstellar travel, we decided we wanted to talk about the possibility of different types of life both on Earth and other bodies within our solar system. As always, if you have any topics that you want to see in the future, make sure to leave it down in the YouTube comments. We'd be more than happy to cover those in a future episode of Not So Serious. We hope you enjoy.
Planet, galaxy.
Okay, let's get started.
Alright, dude, alright.
All right, going on from last week, we talked about interstellar space travel. Obviously, in order for us to even want to achieve that, there has to be some sort of goal or planet in mind where we can actually settle that is not Earth.
But like Earth, and similar to how
But exactly.
same
Right.
conditions
So
as Earth.
today's episode, we're obviously going to discuss how we even construct a certain planet that'd be ideal for us to even want to settle in. And so we're going to talk about the characteristics and qualities of I don't know.
Oh my God!
Let's-
don't-
Searching for life.
I-
We're talking about searching for life.
We start.
All right, Joe has it.
Okay,
I
wait.
can't do
I
this.
have it. Okay, so when we think about alien life, there's several things there's several aspects of it that obviously come in. The first is the type of life that we're looking for, whether we're looking for complex life, simple life, very extreme microorganisms. So there's the kind of life and how we would go about classifying it. Obviously, another key subject in the discussion about aliens is the suitability of different environments to both sustain life and to start life, to generate it. And then lastly, obviously, you have this big question of either life being transported throughout the universe in panspermism, or you have abiogenesis, where life would spontaneously begin from non-life on a planet. And so I think right now we can talk about the different conditions that would make a planet suitable to sustain abiogenesis.
And I think our only perspective is our life as we know it here on Earth, and so the question is more, what characteristics and things we find on Earth would make harboring life more likely. So those are the characteristics we have to look for as we look elsewhere in the solar system or in the universe.
Yeah, and I mean, so we know that there's these classical beliefs that have been held, obviously, about the location of a planet determining potentially its habitability. And so, for example, obviously the Goldilocks zone, where it should be neither too hot nor too cold, is I think the most critical factor that we've been looking at, and it's been the primary factor in determining our search for potential habitable planets elsewhere out of our solar system. And thousands have been found. The closest to us is only 12 light years away, but we haven't detected any signs of life on any of these thousands of potentially habitable planets that we found. So there's likely other factors that go into influencing whether life is either creatable or sustainable on a planet that are other than where it is in terms of its sun.
Yeah, I would also say that the habitable zone, that idea is a bit flawed, as in a lot of scientists are now considering it not the Goldilocks zone where you find life, but instead of just the liquid water zone. This is the area where it's not too hot, not too cold. And so at least in our solar system, we know of one example where us here on Earth, where there's water in the Goldilocks zone.
Yeah.
There's so much water found in other situations, such as the moons around large gas giant planets. And so going further, we have to look more than just the Goldilocks zone.
We found liquid and or gas water in most, I think even most, or a lot of objects around the sun. We definitely, we have it on Earth. There is ice on Mars, and there's also ice on the moon, but there's also, in some cases, there is liquid water on Mars still. There's clear evidence that there has been an abundance of liquid water on Mars with all of the canyons and the rock formations. There's the oceans on Europa. The list goes on. Water, clearly water was a factor that we used to think about when we were looking. Liquid water used to be a key factor, but now I think we know that can't be the only factor.
Yeah.
Nor could it be a decisive factor. You then definitely have things like you might need an atmosphere. You might need also protection from radiation. You might need, and then there's obviously a chemical side of it where you need both organic compounds, either makeable or either obtainable or already there on your planet. There's all sorts of different factors that go into.
And you also have to consider the size of the planet, no? Because it's too large. Or like if it's gas giant, we can't settle on it. Obviously, if it's
Right.
too small, you have to consider like the gravity, those kinds of things where maybe we could just be floating if we go somewhere like the moon,
Right.
It's not normal.
I know, for example, on Earth, so we still largely ignore how life started on Earth, whether it came from a process of abiogenesis where it spontaneously came from non-life, kind of, or whether it was brought to Earth. But regardless, we still largely ignore where on Earth life might have started. It could be at the bottom of the oceans, but it could be at the bottom of the oceans near
like the idea of hydrothermal vents.
Yeah, near
these
those
areas.
hydrothermal vents.
Mhm.
It could also be deep below the Earth's surface, where it's thought that we could have microorganisms that subsist on hydrogen and methane. That's likely too. There's also different theories about ocean shores where you would have an interesting mix of amino acids being produced and of proteinoids emerging from reactions on ocean shores because of the higher heat, and then entering the water as protein droplets. So there's all of these different. So because we so largely ignore where and how life started on Earth, it then becomes very hard to determine the characteristics required to look for habitable planets or life hosting planets elsewhere, because we simply don't know the required characteristics.
And that's why I think an important aspect of our search for life is looking for extreme life here on Earth. And so a lot of astrobiologists don't look elsewhere for life, but they look for, say, the Arctic or the driest of deserts, and looking for what kind of environments life can actually persist in.
Yeah.
Yeah, like the most famous like resilient life is the tardigrade or the water bear. Like that can live in basically any environment. So it gives a lot of hope to like what other environments that it can live in.
Yeah, and so for example, life requires, from my understanding, to have life as we know it, some kind of solvent is needed, and for all the life that we know on Earth, that solvent is water. It is also possible, though, that the solvent could be either ammonia or methane, which would then obviously open up doors to all of these different kinds of ways that life could come about or be sustained.
And so there was a 2013, I think, NASA proposed the mission to Titan, a moon around Saturn, and methane, or Titan has seas and lakes of methane. Except they were going to put a boat on the surface and try to look for life that way, or at least signs of life. But that was never approved of, unfortunately. But it would have been cool.
We know from Earth that extremophile microorganisms exist and in abundance. We have there's for example, if you look at on glaciers, I don't know what the kind of microorganism is called, but I know that oftentimes there's large patches of red on glaciers, and that's some kind of microorganism that just lives on
glaciers.
ice. Yeah, glaciers. um, and then similarly, we know that there's life that can live at hundreds of degrees in those thermal vents under the sea.
Mhm.
And we know that we also know for a fact that organisms can survive in outer space. So
Right.
lichen survives in outer space. And from my understanding, other kinds of organisms have also been tested and have shown to be able to live on Earth, on outer space, which makes the search for life even more mysterious and unknowable, because it's one of these cases where I think if we don't understand how it works when it's shoved in front of our eyes, how can we possibly either look for it intelligently or understand it if we're looking at it somewhere else?
Right. The
I
only
also think-
conditions we have are like on Earth. That's the only thing we can go off of because that's the only evidence we
Right.
have. in
And
terms of
that's
actual
where we
life.
have to be careful too, because I think almost all life on Earth uses water as a solvent, as like a means of energy consumption, but also has its DNA foundations built on carbon, phosphorus, phosphates, and nitrogen. Like there could be other types of life that don't use carbon; they use silicon or sulfur, or gallium instead.
Well, I mean, there is I believe there's this. I mean, there is this concept of the shadow biosphere, which is a theory whereby you could have a completely different type of life even present on, or that could have existed on Earth, or that might still even exist today, but we wouldn't be equipped to look at it. And that theory, at least to me, has two very important ramifications. The first is that it would suggest that if life came about through a process of abiogenesis, that abiogenesis happened twice on Earth, which
Right.
would then speak to the origins of life, where the possibility of life happening. It would speak to the fact that possibility is a lot higher. If there were two separate incidents of it, that's pretty consequential in terms of how widespread life is in the greater universe.
And this is referring to the abiogenesis of two different forms of life based on different
Right.
planets. Okay.
And the second very important ramification of this potential shadow biosphere on our planet, on Earth, would be, and so by the way, I should point out that the leading theory for the shadow biosphere right now is that it would be a non-phosphate based form of life. All life on Earth as we know it uses phosphate, but it is possible that that life without phosphate exists. But then we come to this point where we don't know how to look for it. It could be that it exists in rocks. It could be that it exists in oceans. There are traces of some organism in a place called Mono Lake in California, and that lake is apparently very arsenic rich, and there is potentially an extremophile microorganism that exists there, which would not use phosphate, which would not have a phosphate base, and therefore it would be an entirely different kind of life that could exist in places where we wouldn't expect life to exist, in rocks deep under the Earth's crust. And I mean, if that theory is correct, then it would mean that identification of life elsewhere would be even more of a challenge, given that some kind of other life exists on Earth, and that we can't even identify it conclusively yet.
I think another important idea is also how fast life can kind of appear once a planet forms. And
Right.
so the universe is only about 14 billion years old, and Earth 4.5 billion years old, and so it's an important question of how fast can it show up on the surface and spread.
Pertaining to our discussion before this, when we were talking about this idea, so we know for mostly a fact that the Earth is 4.5 something billion years old,
Right.
and we definitely know that we have found there's conclusive evidence that there has been life on Earth for at least 3.5 billion years. And there's more and more candidate organisms that could be even older than 4.5 billion, going all the way back to about 4.2 some billion years ago. I know that there's two leading candidates for that. Some microorganism that's been found in Australia on beaches, where it lives on the boundary of the water and not the water. And so it means that this microorganism survives very well off the evaporation of water on rocks. There's some organism in Australia and I think there's been traces of organisms out near in Montreal in Canada, where we think that those organisms have been around for up to 4.2 billion years, which would mean that it only took 0.3 billion years for life to arise on Earth, which then suggests that if it took quote unquote such a short amount of time for life to appear on Earth, it would mean that maybe the formation of life in the universe, or the abundance of life being transported in the universe, is fairly high.
Right.
Given that it took so little time. If, on the other hand, for example, the Earth was 4.5 billion years old and life had only started 0.5 billion years ago, that would mean that for 4 billion years there was nothing on Earth. No life had started. But it could be. But if it only indeed took 0.3 billion years to rise, it could mean that life in some form or another is at least consequentially more likely in the universe.
Right.
I think that also that short time frame could also suggest the other idea of, is it transpermia, where it was brought in the early Earth.
Transpermism, yeah. And I mean that is a fascinating idea, at least, that life was brought to Earth, maybe intentionally. That would be an incredible, maybe a little bit too sci-fi ramification.
That break a lot of people's minds. That is actually
if
Right.
life did.
I don't know how well received that would be.
Yeah. Who knows if they'll be intelligent or anything more than like a few cells put together, but
On the other hand, if life did indeed arise on Earth through transpermism as opposed to abiogenesis, then we have this reality that we have to be confronted against, that life is potentially prevalent in the universe. And I mean, we know for a fact that amino acids have been found on at least 2 comets, Wild 2 and Churyumov-Gerasimenko. I don't think I'm pronouncing that right. But either way, the 2 comets that have been visited by probes were both had an amino acid, and actually the same one, glycine. I don't know if that's just a coincidence or whether glycine is just the only amino acid flying around in the universe. Nonetheless, given that amino acids do exist outside of our planet, it does support the idea that life, or at least the building blocks of life, are prevalent in the universe, flying around, and likely to hit anywhere.
And it's not necessarily even the idea of a comet. It could even be, we know that, as you said earlier, Joe, that there's been water and perhaps even life on Mars in the past. And so it could have been a large asteroid impact on Mars, kicked up some dust, and that dust just happened to come in as a meteorite on Earth's surface.
Yeah.
Right.
And the other thing is that another interesting aspect is that we don't know what stage of the development of life is required to kickstart life elsewhere. So by that, what I mean is, we don't know if, for example, bringing a simple organic molecule onto a planet is enough to kickstart life on that planet. So, for example, if life is indeed this thing that is likely to happen out of just simply organic molecules through, RNA synthesis, the operant Haldane theory of spontaneous life on Earth occurring, if that process is likely to occur, then with a very, very simple and probably likely thing happening, life can be kickstarted. If, on the other hand, for complex life to evolve, there's a very complex and unlikely processes needed to happen. Then for life to be transported around the universe, you would need a fairly complex form of life already existing to be transferred around the universe.
Mm-hmm. Yeah, because I know there's a lot of arguments that say that life both needs a reproductive element and an energy creating element in order to create evolution. I know one of the leading theories for life on Earth, at least, is that mitochondria, like the powerhouse of the cell you always learn about in middle school, it used to be its own cell, and there were also amoeba that happened to eat mitochondria, but instead of like dissolving it for its energy, the mitochondria ended up supplying the energy for the cell, and that's how a lot of the evolution came about.
Yeah, I mean, and it's a crazy chicken or the egg. It comes down to, again, a chicken or the egg situation in which we don't know the sequence in which life progressed from its early stages to complex organisms. It could be that cells started metabolizing first and then became self-replicating entities, or it could be that you had chemicals that became self-replicating and then they started to metabolize.
Yeah. I think there was a study in February of this year that they found a parasite called Haenaguia salminicola that has like no mitochondrial genomes. So it's basically a salmon parasite that doesn't use oxygen to create energy. It just purely leeches off of other beings.
Yeah,
so I think that was a main leader towards having like the amoeba and the replication before like the energy production.
Yeah, and I know that Boltzmann, who was one of the founders of modern thermodynamic theory, he wrote a book where he wrote a paper, I'm not sure which, in which he talked about how the struggle for life to occur is not over, and it's not over heat or energy, nor is it over the abundance of organic raw materials. It's over extracting. It's about extracting energy from a general chemical potential in an irreversible thermodynamic process, and that actually that idea then kickstarted someone else's. It won someone a Nobel Prize in chemistry in the 70s, and the Nobel Prize was given over the mathematical treatment of self-organization of life based on chemicals that just existed, and by an understanding of the thermodynamic process of extracting energy from chemical potentials, we can arrive to an understanding of potential self-organization of life based on chemical potentials. So, for example, this idea of this mathematical or chemical idea of self-organization can lead to things like ATP, which is adenosine triphosphate, which is
it's
itself
the main energy source of
the
like
energy source of life.
any organism. Yeah.
And so if it is the case that simply having raw materials and then they will self-organize to make key elements of life, that would then speak to life being fairly likely. On the other hand, as we know when we talked about life before, modern multicellular organisms are so complicated. There's so many different kinds of proteins, of amino acids, of DNA, RNA, all of this. It's so complicated that then maybe then it would be trying to draw the link, at least, between how the very earliest life evolved to how it is now, are things that are, maybe that's something that we can't do yet. Maybe it is that in the same way that we think that we understand how quantum theory works, and we think we understand how gravity works, but we can't link the two very well. We might not be able to link how very early stage evolution led to complex life as we know it, that might be out of the realm of our
I
understanding
think
now.
I think it does beg the question. I mean, this might be a topic for another time, but like, how do you get from cells to human being? You know, like we are
Right.
so
Yeah.
much more complex
Wait,
than
I
just
think Sam, you cut out.
hello.
Yeah, I can hear you now.
How do you get from just random clusters of cells to actual human beings? You know, like
Mhm.
that jump in progression, or just in any animal, I guess, any complex living form is so large. It does beg the question of like, do we really know how we got to this place scientifically? How do you even like
Prove is it just
not
blind
even
luck?
prove it?
Or,
Yeah, how do you even like bridge the gap of that
Right.
of the
Yeah, I mean,
process scientifically, because it's such a long enduring process that we can't ever really prove if we wanted to like recreate that kind of in an experiment, because it takes so long. And then going back into like Earth's history and its past and looking at those organisms, it's really hard to justify where that bridge is like the gap is bridged.
Right.
this is the dogma of evolution, because like people will say, oh, that's just evolution. That obviously makes sense. How can
But
you
that
not
doesn't
get
make
that?
sense.
But then,
Right. Yeah.
but then
Like-
for some reason, then I mean, I'm not disputing evolution in any way, but then for some reason, evolution took a path of purpose. It somehow randomly went, because there's no species, our understanding of very early organisms couldn't have a purpose. We now think that the whole point of a species is to perpetuate itself, but that
Right.
could not have been the biological goal of those very early organisms. There's no way that there's no way that a protocell had the drive to self-replicate in some way.
Yeah.
So
Right.
then I mean, I think this is part of the reason why life on Earth is so interesting, and it has been food for thought for thousands of years.
Yeah.
But how did we get from just simple chemical reactions happening, really, to complex life that evolved a brain and a heart and nerve cells and like digestive functions? That's something that's still puzzles
Right.
me.
I get evolution in the sense that a species has to evolve to kind of fit its environment if it's like pushed to a new place, right? Because certain species, they'll branch off. You'll see that they have like common characteristics, but one natural selection might have helped one species survive in like a desert or something like that. I just find it in my mind, it's so hard to understand how like just cells get to that space of being actual creatures and like actual complex life, where it's not just because we can say life. I mean, I think it'd be great if we found life on another planet, but if it was just cells, it'd be kind of a letdown, because it's like, okay, well,
But I also think
how are we
that
gonna, like, you know?
yeah, I'm optimistic that in maybe not our solar system, but in our universe, that there will be some form of intelligent life, maybe more intelligent than us or less intelligent. Not sure where we fall in that spectrum, but I'm optimistic that we'll find, within our solar system, microbial life and life that's a little bit more advanced than microbial life. And I think, the more we search for life in the universe and hopefully eventually come across it, that we'll see different snapshots that can kind of tell us our own story as humans.
Perhaps.
Or in life on Earth. So by kind of looking out into space and
Because
continuing the search,
there are very important ramifications to what kind of life, if we ever do find life, what kind of life that is will tell us a lot about who humans are and why humans are and why Earth is Earth. Because for example, evolution is supposed to have happened based on natural selection, which means that life is only is survival, essentially. But we found one path of survival. But it's conceivable that, for example, on other planets, the idea is just to get as big as possible. So you might have, I mean, this is just wild speculation, but what we find elsewhere, for example, what if we just found things as big as mountains that were somehow alive or somehow thought? That would be, that's more in the realm of science fiction.
Our perception of life, though, is so skewed based off what we see here on Earth. And so we think, when we think of the classic alien science fiction movie, we think of a being with two arms, two eyes, something like that. So when we think of even just microbial life, we think of microbial life on Earth as being placed on Mars or as being placed on a different planet in our solar system universe. So I think we definitely have to, broaden our perspective as to what life can be elsewhere.
But the thing
And
is
then
that, I don't know. I struggle. It's a little difficult because you also have to consider if we find life on a different planet on space, you have to consider that planet and its environment, right? What kind of things might have caused, whether it was actually came from water or like those kinds of characteristics that might actually just confuse our argument of how life formed more, because like Earth existed with certain conditions for life to happen, right? So if we
Right.
find life on another planet that is different and that maybe a different chemical makeup and stuff like that, then you run into the issue of, well, how do we actually bridge this gap now? Because life may have formed this way for us. It doesn't help us in our process of seeing how intelligent life was formed for us, because the conditions in the environment are so different that what you can take away from that other planet is so small, I feel like, and it's so different.
there isn't the nice consequence that we know so little about the origin of our own life. If we find life somewhere else, it might not confuse us that much because we're already very confused.
That is
Right.
true.
Yeah, I think it all just boils down to we don't know exactly how life started, let alone how it went from a few cells to multi different celled organisms. But then it begs the question, like we brought up earlier, if life happened so quickly and there's a ton of life, how I know a lot of people will be asking, how exactly do we detect life on other planets and other bodies in our solar system?
And why are we not seeing it? If it
Right.
is the fact that life is so common, why are we not finding it? And it could be that this obviously enters the realm of philosophy, borderline science fiction, but we could be looking at it and not seeing it. But I think that the most critical part is, as we discussed with Professor Meyer in one of our other episodes, the search for aliens the search for life elsewhere at the moment is much more in the realm of exploration than it is in the realm of science, because science for us is hypothesis testing. It's, we know this and therefore we can ask this set of questions and we can find partial, complete, or no answer to these questions. But then knowing that, it helps us inform how we can ask the next set of questions. However, with the search for life elsewhere, we haven't engaged in that search in a scientifically rigorous way yet, partly because I think we lack the means to do that. But we've really just been pointing telescopes to places and trying to see if we can find little people. But then on the other,
or something like that.
I would say our approach is explorative in terms of looking at exoplanets, but not here in the solar system. Here in the solar system, we are definitely hypothesis testing on Mars, and in the future, in the missions in 2022 and 2024 that go around Europa and the moons of Jupiter. Like, that's definitely hypothesis testing. That's definitely real science. And I think it's also real science looking at the atmospheres and trying to figure out the elements that compose it. But I think it's more exploration in terms of trying to bridge that gap between there's oxygen in the atmosphere, so what could be on the surface living.
Right, or even more than oxygen. I know if you manage to look at an exoplanet that has an atmosphere and then have some source of light come through it, you're able to look at the spectrum of light and determine, I don't remember the names, but I know there's very prominent absorptions of organic material that only comes from respiratory functions of life. And if we were able to find that in the atmosphere of a different planet, that would guarantee that some sort of respiration is happening on the surface.
I mean, but I think that could also just be a false positive. That could equally well be a false positive, in that what if, but
it doesn't prove, it suggests.
It doesn't.
It heavily suggests,
But it is. I mean, because fundamentally, what are we looking to achieve? Are we looking to build relations or with aliens, or are we looking to find how life started either on Earth or from around the solar system?
I think it's a combination of curiosity and knowing that we're not alone. I think that's a very philosophical question that we ask ourselves, and also I think it's to reflect on who we are as a species by looking elsewhere at life.
Yeah, Mm.
And there's also always an element of discovery with science as well. And
Right.
it would be a massive discovery if we were able to find other
Yeah.
life, let
Mm.
alone intelligent life, but just other life on different planets, you know?
I mean,
Because then it
Right.
begs the question of what even constitutes life.
Right.
yeah.
As we know it, life is something, but it could be something completely different that we have to consider and we haven't considered.
Well, I mean,
Right.
Schrodinger, I know, said that I'm kind of stealing this from stuff that from other. This is other, but Schrodinger definitely said that life for him is something that keeps moving long after it should have stopped. So if you throw a rock, it just stops. If you throw me from high enough, I'll stop too. But in general,
Or you'll start orbiting the Earth.
in general, though, life as we know it is very persistent. It keeps going. It's regenerative. And maybe if we look for life elsewhere that can keep moving after it should have stopped, maybe that's the wrong way to approach it. But
Should we go to Europe and start throwing ice chunks? See if they stop or not.
Jeez.
I mean,
Good
but
Lord.
either way, though, if we find life in our own solar system, that would presumably speak volumes to support the theory that life is prevalent in general, maybe in the
Right.
in the universe, and it was transported to Earth in whatever form we find it. If we find it in microbial form, if we found some kind of life in our own solar system, it would probably speak to it would support the idea that life was brought to Earth, and it would also support the idea that life was probably brought to Earth in a similar state or in a less developed state.
Right.
And then we would then learn a lot about how our understanding of life came about.
Yeah, and we can get into it next week, but then how advanced and how intelligent and conscious the species are can tell us a lot about the progress of like human civilization and how civilization can evolve, whether or not we're cutting edge in the universe or we're approaching what's known as a great filter is like an interesting topic philosophically and psychologically to understand as well.
Yeah, and then I think that for me it really brings back into light what a human perspective is, because we think that we're conscious and that, well, I mean, not that I want to get too deeply into what consciousness is, but humans, at least intuitively, are conscious that they're conscious and they see things and they understand things. But it would be so enlightening, at least, to see if life is developed sufficiently on other places, what their brain is, or what their, not even their brain, because we don't know if they have one,
Right.
what their end goal is. Because for human beings, for millions, or since human beings have existed and animals existed, the objective is survival. And I think that makes that I think underpins our view of the world. It underpins our understanding of it. But maybe we would find other animals or others. If we found life elsewhere, it might be geared with an entirely different purpose.